Week 7, question 1. Diana drew a bar chart representing the quantity of the 4 tree species registered during a biology excursion. Jasper thinks that a pie chart would better represent the ratios of the different tree species. What does the respective pie chart look like? Okay, so let's examine the 5 choices one by one. If we look at A, we don't see anything inconsistent with the bar chart, but let's keep on. If we are able to rule out the other 4, then we will be pretty sure that the choice should be A. If not, we need to probably think more carefully. Okay, let's look at B. So for B, we notice that the dark gray and the white have the same area, which means that they have the same ratios. But if we look at the bar chart, they are not the same. So B is incorrect because it's inconsistent with the bar chart. Let's look at a C. C, so it's not that obvious, but let's look at the dark gray and the black, whether the ratios represent the ones in the bar chart. We notice that if we add up the dark gray, this piece, and the black, so the total area is more than the light gray. But if we look at the bar chart, the sum of the black and the dark gray should be less than the light gray one. So C is incorrect. It is inconsistent with the bar chart. For D, D is pretty obvious because the bar chart tells us that the light gray is the most frequent one, but D tells us that white is the most frequent one. So D is incorrect. If we look at E, so E is different from the other choices in that the light gray is the most frequent and it is more than half of the total. But if we look at the bar chart, we can see that easily that white plus dark gray is more than the light gray, which means that light gray cannot be more than 50%. So E is also not consistent with the bar chart. With that, we are pretty confident that A should be the choice. Okay. Let's move on to question 2. Question 2, we have 2 people, A and B. Each of them has their birthday on the same day. In 8 years' time, A will be twice as old as B. 10 years ago, the sum of their ages was 21. How old is A now? Okay, so for problems like this, I would like to use tables. And when I use tables, so I put now. And in this problem, I have 10 years ago, minus 10, and then I have in 8 years, 8 years later, plus 8. Okay, so these are the 3 time points. And what else? We know the total. The total 10 years ago was 21. With that, we can find the total of now and 8 years later, right? So for example, for 8 years later, it is 21 plus 18 times 2, which is 57, right? What else do we know? We know that there are 2 persons, A and B, and we know that in 8 years, Alice will be twice as old as B, which means that B is going to be 57 divided by 3, which is 19, and A is 19 times 2, which is 38. The question is, how old is Alice now? So now means that we need to subtract 8. 38 minus 8 is 30. So this is the answer. So for questions like this, it is organized to make a table. We probably don't need all the cells of the table. For example, for now, we don't care about the total, but we want to try to organize the information given and also try to see from which path we can find the question that is asked. Problem 3. There are 3 different colors. The number of blue balls is at least half of the number of white balls, but is at most 1/3 of the number of red balls. If there are at least 55 white and blue balls in total, what is the least possible number of red balls? We want to know the number of red balls, but we see that the information, a lot of information has been given about blue balls, so it's relatively easy to figure out the number of blue balls. Let's try that. This sentence, the number of blue balls is at least half of the number of white balls, which means that if we look at blue and white together, then blue should be at least 1/3. So this one implies that B should be at least 1/3 times the total of blue and white. And from the other sentence, we notice that the number of white and blue is at least 55, which means this is greater than or equal to 1/3 times 55. But notice that, so this one, notice that B has to be an integer, so B is at least 19. And we also realize that the number of blue balls is at most 1/3 of the number of red balls. From that sentence, we have B is no more than 1/3 of R, which means that R is at least 3 times B. But from here, we already know that B is at least 19. So this implies that R is at least 57. Problem 4. We started with a 3 cm by 3 cm by 3 cm cube. And then we cut 2 corners. And we want to know what is the surface area of the new solid. Okay, let's look at the original cube, which is a 3 by 3 by 3. What is the surface area of that cube? Each face is 3 by 3, and there are 6 faces. So altogether, the surface area of the cube is 54. Now let's look at if we cut a corner, what is the change in surface area? So let's look at this one. Because we cut this corner, we lost this blue surface. But on the other hand, we gained the shaded blue surface. And for this one, the side, we lost the red surface. But on the other hand, we gained a new face. And also, if we look at the bottom, we lost one face, but on the other hand, we gained a face of the same area, which means that if we cut a corner, if we cut a cube, then it doesn't matter. The surface area of the solid won't be changed if we cut corners. Thus, the answer is 54. Problem 5. 2 to 29 consists of 9 different digits. Which digit between 0 and 9 is missing? You can do brute force by computing 2 to 29. You probably noticed that it equals 2 to 10 times 2 to 10 times 2 to 9, which is 1024 squared times 512. If you're comfortable with the multiplications of large numbers, after a few minutes, if you're careful, you will find the right answer, which is 4. 4 is the missing digit. But today I'm going to introduce modular arithmetic. I'm going to use this tool to solve the problem. Modular arithmetic belongs to the subject of number theory. Okay, instead of giving you a lot of official definitions or formal definitions, I'm going to walk you through some examples. If you look at 3 and 12, if we divide them by 9, the same remainder, which is 3, we see that 3 and 12 are congruent in mod 9. And if we divide 5 and 23 by 9, we have the same remainder, which is 5. We see that 5 and 23 are congruent in mod 9. If you look at 14 and 23 divided by 9, they give you the same remainder. Then we see that 14 and 23 are congruent in mod 9. Next, I'm going to introduce some properties about modular arithmetic. Specifically, we're going to look at 4 operations. Note that here we look at mod 9. You can define in mod 7, in mod 8, in mod 6. But in this problem, as explained later, mod 9 is going to help us solve the problem. Okay, so that's why we focus on mod 9. Okay, so I'm going to introduce some properties. The first one is addition. If we already know that 1 and 10 are congruent in mod 9, which is true, and we also know that 2 and 11 are congruent in mod 9, then the addition rule tells you that if I add up both sides, then 3 and 21, they are congruent in mod 9. So implies once you know 2 are true, then implies that if you add up the 2 sides, they're still congruent. And this is addition. And next, let's look at subtraction. 1 and 19, they're congruent in mod 9. And 2 and 11 are congruent in mod 9. The subtraction rule tells us that if we subtract one from the other one, we still have congruence. Let's subtract the second one from the first one. We have a -1. This implies -1 and 8 are congruent in mod 9. So this is a subtraction. So let's look at the multiplication. 1 is congruent with 10 in mod 9. 2 and 11 are congruent in mod 9. And the multiplication rule tells us that we can multiply both sides. This implies that 2 and 110 are congruent in mod 9. You can verify that dividing by 9, 110, and then divide 110 by 9, the remainder is 2. Right? So the exponent tells us that we can apply exponent to both sides. So for example, 2 and 11 are congruent mod 9. This implies that if you do exponent, let's do squared, 2 to the power 2 and 11 to the power 2 squared are congruent in mod 9. You can verify this easily. The left-hand side is 4, the right-hand side is 121. 121 divided by 9, the remainder is 4. Okay, let's summarize what we have. So we have the addition rule, we have the subtraction, we have the multiplication, and then we have the exponent. Okay. They will be used to simplify a lot of calculations. Okay. So next, let's look at the problem. we want to look at 2 to 29, its digits. We were told that it has 9 digits. Let's use A, B, C, dot, 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 and K to represent the 9 digits. A is the unit digit, B is the 10th, and C is the 100th digit. Okay, and we were also told that the 9 digits are different. So which means that one is missing, because if we look at all possible digits, we have 0, 1, dot, 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 through 9. And the sum of all of them is 45. So now we know that one of them is missing, but we don't know which one. Okay, see that the total is 45. If we know the remainder when divided by 9, then we know which digit is missing. So if we know the sum of the digits, if it's congruent to something in mod 9, then we know which digit is missing. For example, if the remainder is 2, which means the digit 7 is missing. Another example, if the remainder is 4, this means that 5 is missing. So as long as we know the sum of the digits in mod 9, what it is congruent with, then we know the answer, right? Okay, so next we are going to establish a result that can correlate a number and of its digits in terms of a mod 9. Okay, so next we look at in situation. Let's call it n. Let's say that the unit digit is A, the 10th is B, the 100th is C. The mod has many digits. We don't care about how many digits. Okay. And we can express n in terms of A plus 10B plus 100C plus dot, dot, dot. And then we take the digit, which is the sum of the digits. And then in the remaining, we have 9 times B, 99 times C, dot, dot, dot. We see that the second group is a multiple of 9, which means that n is congruent with A plus B plus C, dot, 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 in mod 9. In other words, a number and the sum of its digits are congruent in mod 9. So this tells us that if we want to know the sum of the digits, then we can just look at 2 to 29, what it is congruent with in terms of, in mod 9, right? So we want to know the answer. Okay, so next let's look at 2 to 29. If we can express it in terms of 9, that seems helpful to find out its remainder when divided by 9. But it's not that easy. Fortunately, we see that we can construct 8. 2 to 3 equals 8, then to 9, then times 4. So we have 8 to 9 times 4. Why are we interested in 8? Remember that 8 and -1, they're congruent in mod 9. And by the exponent rule, we know that 8 to the 9th and -1 to the 9th, which is -1, are congruent in mod 9. And next we use the multiplication. So 4 times 8 to 9 is congruent with -4 in mod 9, right? And this is also the same as 5, congruent with 5 in mod 9. So this tells us that if we look at 2 to 29 divided by 9, the remainder is 5. But recall that we established a result which tells us that a number and the sum of its digits have the same remainder when divided by 9. So this tells us that if we look at the sum of the digits, a plus b plus c, dot, 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 until k, so this thing is congruent with 5 in mod 9, which means that when divided by 9, the remainder is 5. And as reasoned earlier, this means that number 4 is missing, or the digit 4 is missing. This is a long solution, but I hope that you have learned a little bit about modular arithmetic and this procedure. And here you see that to find the remainder divided by 9 for 2 to 29, we try to find a number that is as close to 9 as possible. The reason that if you look at 8, the difference between 8 and 9 is 1, or -1. If you do exponent, you will get either 1 or -1, which is pretty easy to handle. Question 6. Jess marks 4 of 8 identical cards with an X and the other 4 with a Y. She shuffles them and puts them face down in a row and challenges Mike to guess the letter on each card. Mike decides to choose XY, 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 XY. What is the probability of Mike correctly guessing all 8 cards? Mike chose a specific arrangement. So basically, we want to know how many arrangements in total. And because Jess shuffles, which means that all the different arrangements are equally likely. So we just want to know how many ways. This is a standard combinatorial problem. We see that there are 8 positions for X. We need to choose 4 positions from the 8 to put X, and the rest will just put Y, right? So how many ways of that? That is 8, choose 4, which equals 8 factorial over 4 factorial over 4 factorial. That is 8 times 7 times 6 times 5 over 4 times 3 times 2 times 1, which is 70. And Mike chooses a specific arrangement, which is a 1 out of the total 70 ways. Thus, the probability is 1 out of 70. Let's look at the next problem. Problem 7. The diagram alongside show 2 quarter circles. So we have 2 quarter circles. One has radius 3, the other has radius 4. We want to know the shaded area. Okay, so let's do the easy part first, right? We see that we can compute the 2 quarters easily. So first of the 2 quarters is 1 out of 4, because each of them is a quarter, then times pi, then times 3 squared, then plus 4 squared, right? Which is 25 over 4 times pi. We noticed that, so in order to make the shaded area, we needed to plus the area of ABC and then subtract the area of CDE. So to know that, we needed to know the length of BC and CD. So for BC and CD, we noticed that BC plus CD, what is the sum? We know that this is 3, this is a 4, thus BC plus CD is 1, right? So this tiny length is 1. And we also know that the two triangles are similar. We have A, B, C, and E, B, C are similar to each other. And we know the ratio, the BC over CD equals 3 over 4. Now, if we combine these two, for example, you can do substitution, you will find it easily that BC is 3 out of 7 because the ratio of BC to CD is 3 over 4 and the total is 1. You can easily guess, right? So BC is 3 out of 7 and CD is 4 out of 7. So we need to find the area of ABC, which is 1/2 times 3 times 3 out of 7, which is 1/2 9 over 7. And similarly, we can find the area of a CDE, which is 1/2 times 4 times 4 out of 7, which is 1/2 times 16 out of 7. So next, I don't have more places. Let me add a page. Okay, so we have the 2 quarters, which add up to 1/4, 25 over 4 times pi. And then we need to add up the ABC area, which is 1/2 9 out of 7. Then we need to subtract the CDE. CDE is 16 out of 7. So we see this is 25 over 4 pi minus 1/2, which gives us the answer, which is B.